G'day legends, Craig from Beasty Life here. Welcome back to another Beastie's Corner, and today we are talking shunts. So this, great bit of gear, essential bit of gear, especially if you're going off grid or have a basic 12 volt setup and you want to keep an eye on it. So really cool. Now this, thanks to my mate Chris down the road, he has bought himself a kick-ass 500 amp hour shunt. I'm going to be hooking it up to his new lithium battery for him. But first I thought I'll pinch it and I'll do a quick review on it and show you. So this is definitely a brand that I would buy, Kick-Ass. Again, not sponsored, not endorsed. I've used their solar panels before. I've got their outdoor projector system. I've got their gang switch, wireless gang switch here, which I'm going to be doing a review on shortly and installing in Beastie. So I think they've got great gear. Aussie run company, pretty sure it's all Chinese gear, but still it's good quality tested stuff that they basically get it from China, make some adaptations, make it better, and then pass it on, and it's very reasonably priced. So check them out. I think you'll find, surprisingly, the gear they got and the value for money is certainly there. So let's have a quick look at this, and we'll open up the box and we'll check him out. When you open the box, what do you get? A bit of foam. So this is the shunt. So basically that's what they look like. They are pretty funny looking things, but basically it's all based around the negative terminal. So the B minus is where the negative lead from the battery runs in. You bolt it onto there. Every other negative load in your 12 volt system then comes off this side. So the shunt is measuring the load through here. So all your negative loads go here, it's measuring everything, and then it can then output from here to the display and let you know what's going on. So that's your shunt. It's got mounting bracket, a couple of screw holes. There's our screws there, a couple of screw holes, and then all we do, let's get this all out, we'll get rid of the box, and then all you do is then hook it up and you're good to go. So that's the shunt, and then you get some connections. So there's a positive wire. The positive wire will go into the battery there. There's a little tiny positive for battery. That will run off to the battery. That'll plug in there, and then the little eyelet will run off to your battery, give you power so that can actually function. And then on the back of this, you'll see there's two cables coming out. So one, temperature sensor, that's the little metal bit there, that's a temperature sensor. You would run that to your battery or whatever you wanted to test the temperature of. And then our adapter here, you screw that end onto that end, like so, and then this end runs into your shunt in there, and that will feed you your information. So we're going to go ahead, we're going to hook it all up to Beastie's Corner, get some power going through it and show you how it all works. Stand by. Okay legends, I'm back. I've done a bit of work off camera just to save a bit of time and make it easy. You don't want to see me just screwing lugs on and stuff like that. So what I've got here is the shunt screwed on, say it's screwed onto your wall. Now this side here, the B minus, that's the battery. So that means that because this is a negative dealing thing only, this is what the shunt does, it deals with the negative side of the battery. B battery, that runs all the way to our battery terminal down there, and I've plugged it in. I haven't used this, I've disconnected this one at the top that we had before, only because that wouldn't reach my shunt. And just for the purposes of this, I've disconnected it. Let's pretend that this cable here is that one. So that would go into the shunt, or this goes into the shunt. It runs through the shunt, and then everything to do with your load for your negative side then goes onto this side of the shunt. So if you had a light, you would do the positive onto the battery side and you'd do the negative on this side. Everything would go onto this. So to make it neater, and this is what I suggest, instead of piling up 20 negatives, if you have a whole heap of stuff going on, you run a negative like I've done up to the bus bar, and then that is now where you put all your negatives. So that will make life easier. All that's really happening is the shunt is just jumping into the negative line so that it can record all the data and send it to your digital display. Pretty much simple as that. So next thing I did is I got the little red wire that came with the supplied eyelet and I put it into the left side, the left one. They're both positive, but just put it into the left one, did it up. You need a tiny little screwdriver for that one. They didn't splurge with the size of that. And then that runs up and that goes to the a positive connection so that it can give some power to the unit. After that, all that's left to do is we hook up so here's our display, and it had the two things coming out the back. One was the thermometer, what do you call it, temperature sensor, and the other was the adapter to plug into, only goes one way. We screw that in there, and then the other end was the one that goes into our shunt. It also only goes in one way. So we plug that in, it's got a couple little lugs so you can't get it upside down. Push that in, nice and easy, and that is it. It's really quite simple. And once it's all done, it's done. You just leave it. You mount that exactly where you want it, where you can see it. Your shunt does not need to be visible. You can hide that down in the dark depths, especially if you run it to the bus bar, because then you've got access to hook things up to it. So if we go ahead and turn the power on, we should see some action on the display. There we go. So it's not going to be calibrated properly. Kick-Ass, pretty clever. They QR code on the back, save paper, download your manual online, print it off if you want to, but just have a read. All the instructions are there, but you need to calibrate your battery. So in saying that, you need to charge your battery to 100%, so there's no more current going in it from your charger. Then you tell the shunt that it is at 100%. Then it can calculate everything from there. So say my battery was at 50% now and I told it was 100, it's going to have all sorts of dramas trying to work it out. But on the display, it tells you current in and out, which is none at the moment because nothing's happening. It's 12.6 volts, the reading, excuse me, on the battery. And the temperature sensor's reading 24.75 degrees, that's quite accurate. And the time remaining. So because there's no current going, it's not really giving an indication. So what I have done though, is I've got some strip lighting over here. I'm just going to turn this off because I want to show you how it reads the current. So I'll just quickly hook this up. This is what you'd be doing with anything that you were going to put into your circuit. You'd put the positive on the positive and the negative on the negative side of the shunt, which is now our bus bar. All right, so when I turn on the unit, it should now give us some type of reading. So our lights have come on.
I can't translate into the battery and the temperature.
And there it is, saying that it is now pulling. My lights are playing up. So it's now pulling, what's that? 0.34 amps with those lights on. There you go, and it started to throw in times and all that sort of stuff. So that's exactly what it's for, to give you an indication. You take those lights off, it reduces the current, take it off, you turn those lights off, it would now know that, oh, there's no more current, it changes your times, and off you go. So very handy when you have fridges and stuff that's draining power and you're off grid and you really want to know how you're traveling for the couple of days you're going to be away, or do you need to get your solar panels out? Do you need to turn your car on? Do you need to start conserving power? All that stuff. Very, very handy to show you where you're up to. So yeah, I hope you guys got something out of that. Shunts are a must as far as I'm concerned. So after seeing this, you know, let me know, would you get one? Do you think they're a great idea, or do you think this really simplifies what we need to do? So I'm very happy with it. So I'm going to give it back to Chris and we'll get it into his car, and I'm sure he'll be stoked. So thanks for tuning in, legends. I'll see you in the next one. Okay, legends, so I went ahead and I showed Chris the video. He is the star of it. So and I said, mate, did you get all that? And his reply was,
"What'd you do, Basil? What does it all mean, Basil?"
Look, I'll do a little bit more. I'll show you exactly how to get your battery calibrated and go through the display and work it out. Once it's set up, it's a set and forget. But yes, that first initial setup of your screen and the buttons and all that can be a bit daunting, I guess. So I will, I'll go into that in a bit more detail. So I think the first thing to note that's important is that the power that runs from our shunt, it needs to be on the whole time. So I've got it just on this side of the battery, just for the purposes of the setup, but the power will have to go on the non-isolated side of your battery if you isolate it. It just got to go to constant power all the time because the shunt needs to be on the whole time. So if you don't have your shunt on the whole time, you only had it, say, turned on at various times, it's not going to know, like if it was off and then you went for a drive and it was charging your battery, well, the shunt won't know because it's not on that it was charging the battery. So you might have put more charge into the battery, but it hasn't recognised it, or vice versa. But if the shunt is on 24/7, anything coming in or going out will always be calibrated. So very important. Yes, that shows that it's after the isolation switch, but you need it on the other side. So I'm just going to leave it on now to show that yes, this is always on, and we're good to go. So I'll jump in to the display, and I've already set this up, but I'll show you what I went through and how to set it up. They're all very similar. You just have to read the manual to work it out. I'm hoping this is the best angle that you can see, but basically to get into the menu to start with, you hit OK, like so, and then up comes our menus. So first one is CAP for capacity. You've got to tell it the size of your battery. So my battery is a 100 amp hour AGM. So you just come across, so you hit OK, come across, you can move your numbers up and down to whatever you need. When you're done, you come back and then go from there. Then we go down to FCV, so that's about the full cell voltage that stands for. So what it wants to know is what capacity does it charge to, like your charger, whether that's your in-car charger or whether you use a plug-in one through the wall. What voltage does it put through, so it knows what the full voltage should be. So that's 14 volts in this case. It's the same thing, you'd go across and you would set it, but you would need to read the manual of whatever you're using. If you've got a DC-DC charger that's putting out 13.8, you need to change it to 13.8 or whatever. So that's how that one will work. And we just go back and we make our way down the list. So now we are at LCA, which is low capacity alarm. So what you need to do, you want to set this to a battery capacity, that if it fell to a certain point, this little alarm in here will go off and it will let you know that it's struggling. So it recommends that it should be 50% capacity of the battery on an AGM, that is. On a lithium it'd be different because they can run down to a lot further capacity. Some can do 80%, some can do 100, but you might set an alarm at 10% or on your lithium or whatever, but on this it recommends 50%. So because it's a 100 amp hour battery, we're going to set it to 50. That way, yeah, once it gets to that, it's time to start charging and it will let you know what's going on. So again, you just hit that, come over and change the top value. We head down to ZCV, zero cell voltage. So this talks about how low a voltage do you want the battery to display before it gives an alarm.
That's boring. You're boring everybody. Quit boring everyone.
So it recommends around 10.5 volts at the minimum for an AGM and 10 volts for a lithium. So again, muck around, have a look at your batteries, read the specs, see what it recommends is the low voltage. It'll have all the specifications listed in it. And then there's a power off voltage, POV is the next one. And so you're telling it at 11 volts, when do we want to turn off the display? It'll be on the whole time. When do we want to turn it off and start conserving energy? So we've set it at 11 volts, which was just default on there as an AGM, so I just left it. But that seems about right. So once you start doing those parameters, if we have a look at this now, it's definitely made a difference to our capacities and stuff. So it's changed it to 60. It says it's 13 volts. Temperature's there and the time remaining. So what I want to show you now is just how, if this is on permanently now, because we've put it on permanent power, I want to show you how things influence your readings and why this is such a handy thing. So at the moment, nothing's on, nothing's happening. Let's say perhaps we go, all right, we're at 60%. I want to charge it. So we're going to get our charger. So I've got just a 12 volt wall charger here. I'll just put this down, I'll need 2 hands, and I'm going to plug my charger in. I've got these little bullet connectors on all of my stuff, like I said, and you just plug it in, and like that. It's a good connection. I'll just turn it on at the wall. And then what you should see is that current, it'll start pumping current in. So if we have a look at that now, our screen's gone. We have a look at that now. Now it's putting in 4.3 amps, 4.2. And now it says time remaining. So that's telling us it now has 9 hours and 38 minutes till it's full. And that will slowly, that capacity will slowly go up. So whether you're charging it when you've pulled into a campsite, whether you've plugged your solar panels in, whether your car's charging it, all of those things will influence charge going into the battery. So that's positive 3.6 amps, and that's just fluctuating depending on the charger that it's doing. So, and then you're like, all right, I've plugged it in. Now I need to go, actually I need to put my fridge on. So fridges draw a fair bit. So I've got a fridge here, just a 12 volt fridge. I'm going to plug that in, and then we'll see a change in the current. This would be just like having a normal item. Positive, negative, wired in. It goes through, and then we'll turn it on, and then we'll see that fridge will kick in a second. That's assuming it's actually on. It might be off. Let me just turn it on. I apologise. Oh no, that's come on. It just took a second. There we go. So that's now using, it was about 3.5 amps. Looks like it's pulling 3 amps, and no, it's negative actually. So it's pulling more than we're putting in. Like, all right, the fridge, don't need the fridge anymore. I'll pull the fridge out, and then that will change. Crash, bang. Now that changes. The fridge is now off. She's jumped back up because we're not pulling those currents that we were before. So I hope that makes sense. That's really it in a nutshell.
Now this is me in a nutshell. Help! I'm in a nutshell!
But yeah, even when it's in Chris's, I might even try and show you by flicking things on and so on, or running a compressor will really smash the battery and so on. G'day legends, back down here the next day in Beasty's Corner. The charge has been going all night, and it's saying, what, 14.2 volts going on our 12 volt monitor, and our shunt is displaying it's 100% full, time remaining 0. So as far as that shunt says, it is full. But this is what I wanted to show you today. In fact, it's not full, it's still putting a 1 amp in. The charger has protection on it. The 12 volt charger has protection, so it cannot overcharge it and destroy the battery. But the charger knows whether it's 100% full or not. Whereas for us, we're still calibrating for the first time. So you can't be fooled by this and think for the first time, oh yeah, it's charged. We need to see that amp input as 0. So the charger will cut off and it will say, no, it's completely full. I'm not going to put any more current in because it's done. So here is our charger up here. This is our 12 volt charger that's coming just from PowerPoint. And as you can see, it's still putting in 14.3 volts charging, and this little display here, it's not full yet, it's still going. So when it is full, it will say full across the screen, and the input will stop. It'll stop giving any power to the, or any amperage to the battery, and then that's when you'll see on the display 0, then you know it's 100%. Okay legends, just in the back of Chris's truck here, shunts in, everything's done, everything's working. So just a quick recap of what it looks like in and how we did it. So he's got a little a box here, a King's box, which runs all his switches and everything like that. But inside, here's our shunt just sitting here screwed onto the wall. Our negative is coming in from the battery. Through the shunt, negative comes out, down to all of his negative inputs on this side. So it's now going to measure everything that's plugged in. So he's got all these switches and Anderson plugs and everything will now get a reading. Then our little positive that comes in, that goes after the fuse, so that if it trips, it protects everything. That's the one that gives power to the display. And then the wire to the display, down through a grommet, out this side, and there it is. So as you can see, it's 100%, time remaining 0, and this is what I was hoping would happen. So I've just topped up his battery. He's got a lithium 100 amp. It's 0 current coming in. So what I did, when I plugged the charger in, the charger now says it's full, 100% full. So it's cut the current off as a protection to say that I'm not going to overcharge the battery. So because of that, full, and because of that, 0 amps, we know it is 100% full. So now, without a doubt, I would be hitting, this is the up arrow on this particular unit, resets it to 100, and then we are good to go. So there you go, legends. That's what it looks like when it's in. I'll just put the cover plate back on and we're all done.
Get out of my sight. Get out of my sight. Get out.
Okay, legends, we're back in the tub at Chris's car. We're going to get this inverter in so that it runs through his shunt. So I've got the cover plate off again so I can show you guys what we're doing. But he always had this inverter. It was just on the other side, and he had a direct battery hookup cables, 0 BNS cables, directly to his battery because it draws so much current. An inverter, you need heaps heavy gauge on that. So that was all good, but all we've done is taken that negative and I've run it behind the inverter, and that becomes our new line into our battery side of the shunt. Like we described before, this is just our new cable. So it will be able to handle the inverter because of the thickness of the cable in through the shunt. It's a 500 amp shunt, so it can handle that sort of current. It then comes out the other side because we want to measure the load that it's going to use when we use it, and then that runs back the negative behind it and then into the negative side of the inverter. So once the inverter's on, it's going to then tell us what current it's using. So really pretty easy. We've just upgraded everything really, the cable sizes, so that he can use it, because from my understanding on the job site, if Chris can't heat up his mini quiches, he gets hangry and then all hell breaks loose. So we can't have that, but what I'm going to do is I'm going to put the cover back on and we're going to start using the inverter, compressor, battery chargers and a few things like that, so we can see the draw and on the screen and in real life use what it's like on the job site. So stand by, I'll get all this sorted and I'll come straight back to you. Okay, legends, quick look at the screen. As you can see that it's at 98%, it's just dropped a smidgen, but we plug something in and we'll get an idea. This is the real workings, you know, or camping, job site, whatever you're doing. So plug a phone in, USB charger on the panel, bang, we're drawing 0.4 of an amp, which is now saying, there's an arrow going down saying we're drawing it out. 99 hours left at that rate charging a phone, which is fantastic. We'll get that inverter on, we'll turn that inverter on, and that will change things. We're charging some batteries. So you turn around, you want to charge a couple of batteries, that's now gone to -3 amps. You know, we charge a couple of these on the job site, whatever we're doing, and then that can make a real difference. So next thing, you know, we might have a compressor or something that we want to run. So if we turn around and I'll get that compressor going, and then you watch this seriously jump up. Compressor. So you have a look at that. That jumped right up to like 119 amps or something, and we only had 50 minutes left of battery. If we continued to run that, that's how long it would take to run down. So it really gives you that idea. What am I using? What am I going to use? This and this and this. So I've turned the car on as well. So the car has a built-in DC-DC charger.
Very nice.
So this charger here is a C-Tech. So it runs through from the alternator. Takes that power, it's hooked up to the battery, and we'll talk more on DC-DC chargers and stuff later. But what it'll do is when it's working, which is soon, it'll kick in, and what it'll do is it will charge the battery. Being it's a 25 amp, but usually it's about 20 amp that it puts in, so it's starting to charge now. So it will then reduce that from our previous high amount of amps. So now we're going positive, which is cool. So it's putting in 20 to 25 amps, and then it will regulate what it's using, what it's not using, up and down. But that's going to charge as you drive. So if you had your fridge, you had this, you had that, it's all going to work itself out in a very handy display, and very easy to monitor. Plus there's alarms. If it gets too low, it starts beeping, it's going off. You can really keep an eye on it rather than guessing how much has my battery got left. So hope this helps, guys. They're awesome. Get yourself one if you haven't got one. Let me know what you think. I really would love some feedback. Did this help? Was it over the top? Not enough? Let me know. And I'll see you in the next one. See you, legends.